Okay, so we are working on focus area called features of functions, and we'll get started on the intro to these notes. Okay, so our first term is called function, and that is a mathematical relation in which each input, which is your x value, is related to exactly one output, which is your y value. Functions can be represented by equations such as f of x is equal to, say, a square root of something. They can be represented by tables, such as t-tables, or graphs, such as the squiggly graph on the right over here. Okay, so here are illustrations that will give you an example of a function. Y equals x plus 5. This function takes an input number of x and adds 5 to it. This function takes the input number of x and squares it for x squared. We have an example of a t-chart or a t-table, and then we have an example of a graph. That's a function. The next term is domain. The set of all possible x values in a given function, the set from which the input numbers come. So on this graph, all of the domain, our x values, go from the start of the graph all the way to the end of the graph. And then we have, let's see, the range is the set of all possible y values that are generated by a given function. So those are your output values. In this graph up here, your range goes from where it starts over here and then up on top here. So your lowest y value and your highest y value. In this mapping type of a visual, your y values are all of the range numbers. So that would be all of the range over here. Okay. Then we have the term relation. Relation is a set of ordered pairs of a number, of numbers. So we have, if you were to have this t-table, your first ordered pair would be -3, 2. Your next one would be -2 and 1. So you would put all of those into a one line to make a set of ordered pairs. And we'll get into more examples of that. Your t-table is a table organizing the input, which is your domain or your x values, and the output, which is your range or your y values. The table is generated by an equation, and we get to choose our x values, and we solve for that to get our y values. The graph is a set of data that represented by points on a coordinate plane. Linear functions produce lines. Quadratic functions produce parabolas, which is this red line over here, this red smiley face or smile looking. Or I could say the green one. If it has a curve like this, then it's a parabola. Graphs of various kinds of functions have unique shapes. A point is the position of x and y of a place on the coordinate plane, represented with a dot on the graph. Points on the line make the equation true when plugged in algebraically. Okay, so a coordinate or ordered pairs create a point. Vertical line test. This is my favorite to figure out if a relation is a function. When given a graph, you just draw a vertical line, and here it's represented by the red line. If the graph intersects the line more than once, it is not a function. So here we have, no matter where you draw the line on the graph, if it hits it one time, that means it's a function. So this is a function, this is a function, and then here I draw the line down, it hits it 1, 2, 3 times, so that means it's not a function. Our x value is our independent value, and it's the first number in an ordered pair. Our y value is the dependent variable, which is the second number in the ordered pair. Independent variables are input values that are chosen to calculate the output values. A dependent variable is the output. That's the result of the input value. So let's look at what a function is now that we're done with our definitions. So here I have this little function machine. So what is a function? You input any number. So I'm going to take, let's say, a 2. And it's not going to let me grab it because I'm in this. But if I were to take a 2 and input 2 into my machine, and my rule is 2 times x, which is my 2 over here, plus 3. So 2 times x is 4, plus 3 is 7. So my output would be 7. Okay. If I were to input, let's say, if I were to input 3, I plug in 3. 2 times 3 is 6, plus 3 is 9. Okay. And then you could do that with all of them to find the answer of the output. Equations versus functions. When we have an equation and a function, we have equations look like this. X plus 3 equals 10. Okay. A function can look like this, have a graph here, where a day is, if day equals Monday, then the output is cereal. So that can be a function. It cannot be an equation because there's nothing to equate there. So if we were to look at an input and say the input was Monday, that means the output is cereal. So if you're figuring what for breakfast is and you have your function machine and today is Monday and I would input Monday into my function machine, out pops cereal. So that would be what I have. Okay. So that's two separate things for equation and functions, but they both share in the sense that you can have y, your output, is equal to 4x plus 10. Okay, so this equation here is not only an equation, but it is also a function. Okay, so the function has a y as an output. Your equation, what makes it different is that it's telling you what your output is. Okay? A function has special rules. So it must work for every possible input value, and it has only one relationship for each input value. So only one. A function relates each element of a set with exactly one element of another set. So if we look at this mapping, that's a type of way to figure out if something's a function. If you notice, each dot on your left side has one output. Okay. So if you know, two important things to note here. Each element means that every element in the X is related to some element in the y. Exactly 1 means the function is single valued. It will not give you two different outputs for the same input. Okay, so what does that mean? So here's an example. Here's my input over here on the left, and it's outputting two different numbers, two different values. And that can't be possible. Okay, so that means it's not a function. Okay, this is a function if I have two different inputs with the same output. That can happen, but you cannot put the same input in and get two different ones. Okay, you can only get one output for an input. Okay, so here you're going to practice, are the following a function, yes or no? So we have our x values. X, our 3 gives us a 9, our 1 outputs a 1, 0 outputs a 0, 4 outputs 16, -4 outputs 16, and etc. So let's look at that. We have two different inputs are getting the same output. Okay, and if I go back and I say, okay, exactly 1 means the function is single valued. It will not give you two different outputs for the same input. Okay, so that doesn't apply here because we have two different inputs and we're getting the same output. So that can be possible. So that means it is a function. Okay, so we have 3 to 9, 1 to 1, 0 to 0, 4 to 16, -4 to 16. It's the same thing. All right, but they still have one output. Okay, so that is a function. Now we have a graph. Again, I do my vertical line test, and right here, we're seeing that it hits it 2 times. So that's a big no-no. It is not a function. Let's look at ordered pairs. You can write the input and output of a function as an ordered point, such as 4, 6. The input comes first, then the output. So we know that for ordered pairs, we have x and y. X can mean domain. It could also mean input. So here we have input. Y can mean output or range. Here we have output. This can also be shown over here. I'm showing you as x or f of x. So when writing functions, you may see and you will see f of x is equal to some kind of equation or function. F of x also means y, or your output. Okay, so it's what is the answer or your output when x is some number. Okay, so f of x also means y. A set of ordered pairs can define a function. For example, we have 2, 4, 3, 5, 7, 3. This is a function because for every x value, there's exactly one output, which is your y value. The domain for this set of ordered pairs is 2, 3, and 7. Those are all of the x values. The range is 4, 5, and 3 because those are all of the y values. What else can we do with ordered pairs? Well, we can, again, see if it's a function. We can plot it on the graph to make a graph. We can order them. We can make a t-chart with them. There's multiple things. We can use the ordered pairs to find slope. We can use them to find the answer to an equation. Again, many things we can do. So I'm going to pause here, and this will be part 1 of this set of notes.